All right, so here we go, page 7. After this, only one more page left. So your page 7 looks like this, exactly like this. As a matter of fact, I'm going to just do some from page 7 for you. What? I know that's totally against what I just said about not doing any of the problems that are in your packet, but you know what? I'm gonna do it. What can I say? So, and this will reward those who actually watch the videos. Especially the ones who are watching the videos or need to watch the videos are the ones who probably need help. So I'm going to help you even extra. And I applaud you for taking the initiative and watching the videos so that your problems can come out right. So here we go. So now we have order of operations with fractions. So that means we are doing PEMDAS. Okay? Let me make this actually lots bigger. It's got the space here. Okay? So we're going to do PEMDAS. You know what that means. Please excuse my dirty beep socks. Well, that's how we said it in the hood. You guys might know it as please excuse my dear old salad. Just saying. Parentheses first, then exponents that you multiply or divide, add or subtract. So remember, multiply or divide, what do you see first? Add or subtract, whatever you see first. That's after parentheses and then exponents. So let's take a look at what we have. Do we have any parentheses? No. Check. Do we have any exponents? No. Check. Do we have a multiplying or dividing problem? Yes, we do. See it? So to multiply these two fractions, just like we've done before, here it is. I'm going to highlight, see if I can reduce either this way or this way. And I can. How can I reduce here? Any number will go into itself one time. Remember what I've been saying about a 1 and a number that's with it? I'll reduce as low as possible. So this is what we're going to do. Remember, reducing is numerator to numerator. Looking diagonally is just for, reducing is looking diagonally. When we actually have to multiply, you're going to go from numerator to numerator and then denominator to denominator. So basically what I'm saying is this. Multiply straight across after you reduce. 1 times 4 is 4. Now, 1 times 1 is 1. But please remember, anytime we see a 1 underneath a number, it's really just that whole number. So this whole multiplication problem equals 4. Bring down the rest, which is minus 3. Guess what? We've done multiply, we've done divide. Add or subtract, whatever we see first. We only happen to have a subtraction problem, don't we? 4 minus 3, answer is 1. Let's go to the next one. Okay. Put PEMDAS over here. I bet you I can get that in there neater. Come all the way. P, E, M, D, N, S. Okay? Going for number 2. Okay, so number 2 is over here. Okay, so let's take a look at what we do first. Do we have any parentheses? Nope. Do we have any exponents? Nope. Do we have any multiply or divide? Yes, we have this multiplication problem, right? So let's multiply these two first. Okay, I'm going to look diagonally to see if I can reduce. That means looking this way or looking this way. Okay, that's not going to reduce. Neither is that. So we'll just multiply straight across. 2 times 6 is 12. 7 times 1, 7. Okay, now I've always told you that don't worry about changing this into a mixed number until you're completely done. Leave it as improper until you're completely done with the math part of it. Okay, until you're completely done with the problem. Okay, so this is what we have left. We did the multiplication, bring everything else down. So multiplication is done, division is done. What's next? Add or subtract, whatever we see first. Whatever we see first. So what do we see first? We see a subtraction problem. Just because the addition problem is there, and the A happens to come first in PEMDAS, you got to remember, it's add or subtract whatever you see first. Okay? So this is what we see first. I'm going to do that over here. Remember with adding and subtracting, we need the same bottom number. And as you can see, we can use bottom number 7. 7 will go into 7 one time. 4 times 1 is 4. 1 will go into 7 times. 2 times 7, 14. Right? So now we can subtract. Now if you're looking at this, oh, this one was tricky. If I subtract here, I'm going to end up with a negative number. 4 minus 14. Oh my gosh, I'm going to end up with a negative number. That's fine. So I have negative 10 over 7. And that's fine. Just leave it like that. So what we're going to do now is the last part. And that last part was adding the 12 over 7. Okay? So now I'm right here. Because I just did that. Now I add 12 over 7. The good news is they both already have the same bottom number. Okay? I need to clear out for a second so I can show this to you clearer. So where we are is this. 10 over 7 plus 12 over 7. Okay? So, I don't have to do the matching bottom number thing because it already has matching bottom numbers. And I said, even though I said there was no integers on the sheet, this one was tricky because it is an integer problem now because we ended up with a negative. So, again, follow your simple integer rules. What do we have when we have a negative plus a positive? By now in your head, you should be saying subtract. Keep the sign to the higher number. That is correct. So I'm going to subtract these two. What's the difference between 10 and 12? 2. What digit was higher, the 10 or the 12? The 12. The 12 happened to be positive. So I'll keep my fraction positive. Answer for this one is 2 over 7. Hopefully you won't have any more that's that tricky. So I will do a few more. Okay? So, going through PEMDAS, parentheses, none. Exponents, none. Multiplication or division, yes, right here. So let's divide. Remember when we divide, we keep the first number same, change the multiplication, and flip it. Which means we're going to multiply the inverse. Oh, I didn't flip it. The inverse operation. So add 5 over 4. See if I can reduce. And I can reduce here, and I can reduce here. Multiply straight across. 2 times 1, 2. 1 times 1 is 1. So as you know, I can take that out and just leave the whole number of 2. So all that division just equaled the number 2. Bring everything else down. You have a whole number minus a whole number. No need to turn them into fractions. 4 minus 2 is 2. Okay. Let's do another. Number 4. Here we go. All right. See what we got. Parentheses. Are there any parentheses? Nope. Exponents. Nope. Multiply or divide. Yes. So again, the first one same. Change it to multiplication and flip. I'm now going to highlight to see if there's anything I can reduce. That's not going to reduce, but these will. 2 will go into itself 1 time. 2 will go into 4 2 times. Now I'll multiply straight across. 2 times 1 is 2. 3 times 1 is 3. That's 2/3. So that means all of that was 2/3. I'm going to bring the rest down. Okay, so we did all the multiplying and dividing. So what's next is adding or subtracting whatever we see first. We see this first, don't we? Now, you have 2 whole numbers, so there's no need to change them into fractions. There's no need to do all this and trying to find a matching bottom number because matching bottom number is 1. And remember, if the matching bottom number is 1, or if the bottom number is 1, we don't really need it. So really, I just have 5 minus 4, which is 1. Now, I'll bring down the rest. Looks like this. Now, this one, you are going to need a matching bottom number, okay? Because that 3 is not a 1. So let me set it up horizontally. Remember, just put 1 over 1, 2 over 3, find a matching bottom number, and as you can see, it'll be 3. 1 will go into 3 times. 1 times 3 is 3. 3 will go into 3 1 time. 3 times 1 is 2. So there we go. Remember, this was adding. So I have 3 plus 2 is 5 over 3. Can we keep it that way? Nope. You got it. So we have to change this to a mixed number. Now you have everything you need to put your mixed number together. 1, I'm trying to stay in the shot here. Remainder 2, bottom number 3. So this is 1 2/3. I'll clear that out again. So this one should be, try not to use weighting, 1 2/3. Okay. See if I have enough time to get another one in. Here we go. Parentheses, nope. Exponents, nope. Multiply, divide, yes. And do you really think I need to turn these into fractions or to even flip it? I don't, because they're both whole numbers. If they're both whole numbers, just forget that they're even fractions, okay? So there's no need to do this and then do this, because what will happen is this, right? And basically, the funny part about this is that you have, those will cancel each other out, okay? And it's still going to give you just 42 and a 7. See that? 42 and a 7. It would look like that. And what do fractions mean again? Divide. So 7 will go to 42. So again, you'll get the same answer if you did that and took the long way around, but considering that they're both whole numbers, don't even worry about making it to a fraction. Just how many times will 7 go to 42? Not sure? Check. The multiplication chart. Throwing up the wrong sheet again. Oh. There it is. There it is. Okay. So check the multiplication chart. And you're looking at how many times 7 will go to 42. Go in the 7 column to get 42. Boom. 6. So you know all this equals nothing but 6. Okay, so took that out. Now you have a plus 1/5. Now you got to do a matching bottom number thing, right? Okay. Matching bottom number will be 5. 1 will go to 5 times. 6 times 5, 30. 5 will go to 5 1 time. 1 times 1 is 1. And we're going to add them together. We have 31 over 5. But you know you can't leave it that way because it's improper. 5 will go into 31 6 times. 6 times 5 is 30, with 1 left over. Now you have 3 parts you need to make your mixed number. 6, 1/5. And remember, that was for this answer right here. All right, I have 1 minute left on this video. So, just taking at this, look at this one. I hope set this one up because I don't think I have enough time to solve it. You have no parentheses, you have no exponents, but you do have a multiply. So you need to do this. Okay? Once you find the answer to that, subtract 2. Good luck to you. I'll see you on the last page.